All right, welcome everybody. Thanks so much for being on our Fleet School live session and for watching our training session today. Really excited to be talking about remote monitoring and predictive maintenance. We're going to be talking about Fleetguard Fit, which is part of the Fleetguard portfolio of products and solutions for diesel-powered customers all over the world. And I'm really excited to have a couple of subject matter experts to join our session today. We've got Matt Ferguson and Phil Martin. Matt, Phil, you guys want to just maybe give a little bit of context to who you are and how you're part of the conversation today?
All right, thanks. Thanks, Jay. I'll kick off. So I'm Matt Ferguson, uh, Chief Engineer and Global Product Manager for Fleetguard Fit. I'm based in Nashville, Tennessee. Don't let the accent trick you. Spent first 50 years of my life in Australia. So I've been in the automotive and mining industry for around 38 years, and been part of the Fleetguard Fit product for probably the last 8 years. So I think I'm well placed to participate here today. Thanks, Jay.
Yeah, and my name is Phil Martin. I am our global product and technical advisor for the Fleetguard Fit product line. I'm located in Cookeville, Tennessee, at our tech center that we have here. Been worked a better part of a decade in new product development, developing liquid filtration products, whether it be lube modules, fuel modules, things of that nature, and the different components that go in those. And been working on Fleetguard Fit for, I guess, going on a little over 3 years now. So
Awesome. Well, welcome, guys. Thank you so much for being here and for sharing some insight as we go through our session today. So I want to just jump right in. I know we've got some questions for us to be kind of walking through today. And really my first question is, what is predictive maintenance? When we talk about, we're going to talk about remote monitoring, but predictive maintenance or condition-based maintenance, these are kind of some phrases that we hear around various industries that are kind of around diesel markets. Can you maybe just give a little bit of context to what is predictive maintenance or condition-based maintenance, maybe for the casual listener that's maybe hearing for this for the first time?
All right, I'll take that one. So predictive maintenance is knowing in advance when a piece of equipment, or in our case, the oil and the filters on the engine are in need of maintenance. Condition-based maintenance is actually changing those filters and oil out at the optimum time. So combine them together, and you're doing your maintenance events in a planned environment, maximizing the filter and oil life, and reducing, just as importantly, reducing your environmental waste associated with that service event. So
Yeah, and I guess historically, when you think about whether it's over the road trucking or if it is some sort of off highway situation like mining or construction, historically you kind of have set maintenance intervals, but you may not really have a good idea of when something's going to need replacing until it breaks, right? And so, not really having that crystal ball to understand when's the best time to be changing this versus when do I have to change it. And so, this kind of, I guess, bleeds into that space of having something a little bit more like a crystal ball that can help maintenance folks that are taking care of equipment or taking care of vehicles really get a better sense of when's the optimum time to be servicing.
absolutely. So if you think about, most of us drive modern cars, and you see a light on the dash that says your oil is due for change or due for a service event. Most of that's based on a calendar, perhaps miles or kilometers, depending on where you live, or some other metric that says, "Hey, go change those consumers or service your vehicle." So knowing when to do it, we are measuring the exact parameters around those filters and the oil conditions, so we can guide someone to change those out at the optimum time.
Fantastic. No, it's great. So it's kind of the future. I mean, I think this is kind of what we're going to get into a little bit more of, but trying to take things from kind of the status quo, how it's always been done, and really trying to put information in the hands of the customer to make smarter choices in the way they take care of their equipment. So I name dropped Fleetguard Fit at the beginning of our call, but again, maybe somebody new that's not familiar with that name or that term, or maybe isn't all that familiar with Fleetguard. What is Fleetguard Fit? And once you explain a little bit of that, how does it work?
Sure. Yeah, I'll take that one. In terms of what is Fleetguard Fit, so the word FIT stands for Filtration Intelligence Technology. And the Fleetguard Fit solution as a whole is a real-time monitoring solution that allows customers to get real-time data and while remotely monitoring their engines. And so we are monitoring the health across the different filters on the engine, whether it be air, fuel filters, lube filters, as well as oil quality on the engines. And so while we're monitoring those, we're getting that data in real time, as I said. And while we're getting that data, we're able to put in certain thresholds with those different parameters to trigger different alerts when you are actually crossing limits that need to be that you need to be alerted for, and that shows the true condition of those filters or the oil in that case, and therefore you can take the appropriate action. So those are kind of the features that I just explained of the system. And what those features do is they lead you to the benefits that you see on the right side of the slide here. So those benefits being reduced unplanned failures and establishing a maintenance schedule that is predictive or condition based, and which all of that will lead to optimizing spend in your maintenance. And while optimizing the filter usage that you have on your vehicles, you're going to obviously have a reduction in the carbon footprint. So all those together pair well with to kind of have a features and a benefits package with the system.
Awesome. So a little bit about how it works, right? So somebody might be sitting here going, okay, I can see the benefit, but how does this thing, how does it really, where's the rubber meeting the road? How does this thing actually work? Because can you maybe walk us through what we're seeing here on the screen?
Sure. And Jay, so we take a suite of sensors that we mount onto the engine or the equipment. They all feed into the FMS box, which is the microcontroller shown in on the left in the middle of the screen there. And then they feed information into a telematics box, which broadcasts all of those parameters into our Fleetguard Fit cloud, where the calculations and algorithms are run. The data is available for the consumer to be able to view current data, historic data, and they'll be in different states of, like the filters will be in different states of warning or loading. So we'll have critical warning state or green for good. We can send those parameters into a customer asset management system as well, where we have one customer where we generate work orders so no one has to touch anything, and a work order pops out at the right place for someone to do the maintenance on that particular consumable. So getting back to the sensors and harnesses and everything that we install on the engine, they're totally customizable. So we can do 1 to 6 air filters depending on the engine type. We have one customer that has 4 different stages of fuel filtration. We have oil filter differential pressure sensing, and probably the jewel in the crown is the oil quality sensor, which is embedded into the clean oil side of the engine and gives us the insights into the engine oil, which I think Phil will be able to tell us a little bit more about.
So is there anything, you mentioned these sensors, is there anything particularly special about the sensors, or maybe, for somebody that's maybe hearing this for the first time with questions, what's the real, I guess, expertise we're bringing to the table beyond, it's collecting this information, but how do we process that and make it usable for the customer?
The sensors aren't anything special. I can say that they're extremely reliable, and they don't create any additional opportunity for a downtime event. For example, if one happened to get broken off or something, it won't leak oil or something of that nature. But where all the magic happens is in that FMS, or filtration monitoring system, box, and then what we also do to enhance the data in the cloud. So the sensors are sending analog or digital messages into that microcontroller. We convert them into something meaningful and then give that back to the customer.
So in a lot of ways, we're not really just providing a big data dump to the customer and expecting them to have to sort through it and make meaningful use of that data. We're essentially delivering this to them in a way that they can read this, understand it very easily, and go make smart decisions about their equipment.
Right.
Absolutely. So
Yeah.
those
So
alerts. Sorry, Phil, you go.
yes, I was just going to add that the data is the gold for us, as we are in the realm of the filtration world, right? And so the data is what it's super meaningful for us, but it may not be as meaningful to the customer in the format that we receive it. But then we take that data, and from the science of the filtration side that we understand so well, being a filtration company, we're able to use that data and convert it into just the meaningful insights to a customer that can give them the real actionable information that they need to know, okay, we're telling you that this filter, the life of it has finally reached the end, and it's time to be serviced. Or there is, even though the calendar might say it's time, there's actually more useful life remaining on this filter, and here's the data to back that up, right? And here's why, not, most of these filters are ones that we designed to begin with, right? So we know the limits of these filters. We know how they were designed to work in their optimum condition. And so that's where, when you pair the two together, the data as well as the filtration science behind that, we're able to offer a further solution for them.
And you kind of touched on it a little bit, Matt, but one question I could see folks having is how you mentioned somewhat customizable. Let's say we've got somebody that's interested, but they're really only interested in maybe oil quality, or they're interested in oil and the oil filter. What kind of limitations or what possibilities are there for customizing, based on their particular application?
So generally, we're able to customize completely from, like you say, just the oil quality through to the whole suite of sensors. A lot of value comes from the air sensors alone. They're one of the things that tends to hold you up more than maybe an oil filter that will bypass, and the engine will continue to run. Fuel filters would be one of those ones that will stop you in your tracks if the filter's blocked. So I think the choice is entirely up to the customer, and we've done some very creative stuff for different customers over the last 7 or 8 years. So it's entirely up to them, but I would recommend oil quality, air filter, and at least stage 2 fuel to get the most out of the system. I think there's so much to be gained by having the system connected. Crazy not to take advantage. And all it is adding, like Lego, more sensors to the kit to get the most out of it.
I know we're going to talk about kind of applications and kind of real world scenarios and some case studies and things like that in just a moment. But, I would say also for anybody listening, this team's got a lot of experience with a lot of different market segments and types of equipment, types of engines. And so, I think part of coming to the table and asking some of these questions and trying to learn, definitely leverage, this team here and understanding what kind of equipment do you have? How do you plan on using it? What benefits are you trying to get out of this? And kind of even having that consulting conversation probably will help you get a better understanding of what you should be doing or based on the, possibilities that are in front of you here. So I wanted to move on. Oh yeah, go ahead.
I was just going to say, Jay, it's not just buy it off the shelf and you're left to your own devices. We have a team of engineers that can travel pretty much the globe if need be to help with the installation. We have a library of installation documents and all that sort of thing. So we're well versed in helping people get this across the line.
Absolutely, yeah. You're not going to be trying to figure this thing out on your own. There's a lot of experience we can bring that we would bring to you to help make sure you're in a good place. You mentioned oil quality, and we talked a little bit about that a second ago. And one of the obvious questions that comes to my mind is, hey, oil sampling programs and oil analysis has been around a long time, and when you kind of think about traditional solutions like oil sampling versus having kind of this real-time remote monitoring type of setup. Can you maybe just talk a little bit about the differences there and why someone might want to make the jump from hopefully they're doing oil sampling, but if they are just doing that, kind of why there's a good reason or good benefit to make the jump from doing that over into the remote monitoring?
Yeah, no, it's a good question, and I think that where the value comes to the remote monitoring, it is the fact that it's real-time data. It's what's happening right now, and therefore you can take the action much sooner if needed. And you mentioned oil sampling, and oil sampling is something that we certainly still advocate for. We definitely don't want to send the message that this is to actually replace the oil sampling. And oil sampling, there is a part of our product line that's mentioned here at the bottom, the monitor fluid analysis program, where we still absolutely encourage the oil sampling. But what these two do is they complement each other well. And the analogy we often use is an MRI versus a biopsy from like a medical standpoint. And so the MRI is going to give you the scan. It's going to give you the indication that, hey, you need to look into this further. There's something not right. And the biopsy is right. It's going to be a deeper analysis. It's going to tell you more of the actual root cause for what's going on. And so the MRI in this case would be the oil quality monitoring in real time. We're monitoring the different properties of the oil, and monitoring those properties is going to give you that information and that data to help you understand when something's just off, something's not right. And then when taking the oil sample, that will give you more of that biopsy to say, here's a lab type of analysis to help you understand, what's happening behind the scenes, what's the deeper story, right? And so, the majority of what's shown here on the slide is kind of unpacking what we do with oil quality monitoring. So this is more of that MRI scan, if you will, and what's happening in real time. And so, it's kind of a busy slide, but I'll point your direction to the diagram on the right side of the slide where we have the different parameters in red. These parameters in red it's the raw data. So it's the data that the sensor is picking up in real time, and that's density, viscosity, dielectric constant, and the temperature. So we're able to take that information, that raw data, and we apply our proprietary algorithms to that data. And we're able to generate what we refer to as the process data. So the process data, when you align it with the different thresholds and conditions that we put forth, that's where it becomes meaningful data to the customer. That's where it's where they can take that data and say, okay, now I know what to do with that. So there's the CDN, and that stands for cumulative degradation number. That is a number that we've created. That's not an industry standard. That is a Fleetguard specific number that we have created with our algorithms. And then there's KV100, which stands for the kinematic viscosity at 100 degrees Celsius, and then the density 100, which is density at 100 degrees Celsius. And so we have different limits for each of those parameters. CDN is going to be one that correlates well with and responds to parameters like oxidation, TBN, and TAN. TBN being total base number, TAN total acid number. These are the common parameters with oil analysis that people in that industry very much focus on. Oxidation is probably the key one and the leading parameter today to show the condition of the oil in terms of how it's degrading. So how much, kind of correlates well with how much additives are left, how much oil life do I have before it's time to service this oil. And so the CDN will respond to those parameters and kind of helps understand when it's time to change the oil, when it's reached the end of its life. Whereas the viscosity is a key one to help pick up on different anomalies that are happening. And we'll give a few examples here in a few slides of what this looks like. But viscosity, you want it to it has an upper and a lower limit, and you want it to be right between those two. If it goes too high, that's a bad thing. But also if it goes too low, that's a bad thing. And so we'll give some examples of what that might look like when something does go a little wrong on the engine here in a few slides. So that's kind of that in a nutshell of where the benefit comes from. Understanding what's happening in real time is much better than having to be just reactive when something ends up failing. The lab analysis certainly has value, but there is a little bit of a delay to that. That's just part of the reality of taking oil samples. You take a sample, you send it off, the lab finally gets to it, they send you the results back. There's a little bit of a delay there, and you're not taking a sample every day either, right? You're taking one at some sort of cadence normally, and so what about in between, right? When you're exposed, and so this helps prevent some of that exposure.
That's great. That's fantastic, Phil. And I really like the MRI and biopsy analogy. I do think that's great. And maybe for somebody that's listening, if your particular fleet or your setup, if you're not even doing oil sampling, that's kind of like never going to the doctor, right? I mean, if there are problems brewing under the surface, you're never going to know until something really bad happens potentially, right? So definitely complementing each other. I think that's a great way to put this. We're not saying this is here to remote monitoring is not here to displace or obsolete oil sampling.
Mm-hmm.
It can kind of do things that remote monitoring can't do, but you do have that delay. And so being able to see some of these things in real time can prevent, potentially catastrophic things from happening that can put, equipment down or out of service for a while. And, certainly the repair bills that come along with that. So I think that's a great way to kind of give that analogy. And yeah, for CDN, being that sort of an in-house kind of created metric for us. If somebody goes and Google CDN, if you don't see anything out there, that's why, right? It's kind of in-house information for us. So another question, I did want to get into some of these specific examples, but from an application perspective, I know sometimes with our audience here, we can have a pretty wide range of folks on, from everything from on highway trucking to oil and gas to marine to power generation, mining, kind of everything in between, rail even possibly. Can you talk a little bit about benefits, kind of applications that seem to benefit really well from using this technology, from your own experience and from customers that have been using Fleetguard Fit?
Yeah, so if you click to the next slide there, we've got hardware Fleetguard Fit kits on everything that's displayed there. Basically any diesel or even natural gas powered engines we're able to connect to. Obviously, a natural gas would have fewer filters to monitor, but the value from the air and the oil condition does not change. So the people that benefit the most are the ones that are, in the harsh environments, like, you've got your mining, oil and gas, farming, forestry, could even be a on highway truck on dirt roads all the time. So anyone that's a high duty cycle even Then the next category would be the people that have engines that are expensive to replace. So pretty much anything high horsepower, but also expensive to replace could be getting to the engine or getting it back to somewhere where the engine can be changed out. So that's also a consideration. Mission critical engine, so something that's maybe a power gen unit in a hospital, maybe a water pump that's dewatering somewhere critical. It could be, the smallest engine might have the biggest impact on the environment where it's working. So, we've seen engines, if they're down, cost $10,000 an hour, would not be uncommon. So, for that kind of commitment to downtime, you really want to have everything going for you. There's probably another couple of cases of product issues. Some engine manufacturers look to us to fill the gap between working out what's wrong with an engine and the repair, getting some early insight before that. Perhaps majority of those comments would be around maybe oil contamination. And then one last one, Jay, would be the rental market, knowing that the equipment's off under someone else's supervision, and knowing that the filters and the oil is being changed, we can tell from a distance that those maintenance events have been done. So equally as important. So.
That's great. Yeah, I think about a couple of examples that popped in my mind as you're talking to mission critical, or if it's a piece of equipment or engine that's sort of the linchpin, right, in some sort of operation like you were talking about. And I know we've talked in the past about examples like particular equipment, maybe on a mine site where there's one of those things doing a lot of work and everything else around it's kind of dependent on that thing working. And if that goes down, kind of everything stops, right? So that would be a great example of the type of application where you really the customer is going to really see the benefit, because even if it helps prevent one thing from happening, it easily is going to pay for itself probably in multiples.
Yeah, an excavator might be loading 8 or 10 trucks, for example. So I mentioned the engines that are the potential for gaining for the self-preservation of the engine. But one thing I did kind of overlook, and it was in the benefits slide at the start, is the environmental impact on utilizing all of those filters and oil to its maximum. So we're finding a lot of customers have a ESG program that this complements rather well, and they like to promote that they're doing everything they can for the environment. So
That's great. Yeah. So I think we've got some examples in here. I'm going to pivot and let you guys talk through a few of these, and just we've kind of talked in sort of generalities about the benefits and ways that this can help somebody. But I think it's really important for anybody that's watching this to see some real world examples of how this data, delivered in a nice and easy to digest format, can help them make better decisions that obviously provide a positive impact to the bottom line of their business. So I want to turn it over to you guys and let you talk through a few of these examples for us.
So this probably is one of my favorite case studies to share. This customer shifted from a time-based maintenance to condition-based maintenance for their oil.
Which that's pretty typical, right? I mean, time-based maintenance. I mean, you mentioned earlier your example about just our own personal vehicles, but it's really kind of the same scenario even for big trucks and equipment. Hey, change these things at X number of hours or X number of miles or kilometers, and that leaves a whole lot of room for possibilities of things to go wrong before that, right? So, sorry, I didn't mean to cut you off, but
that's all right.
This is kind of proving that.
those alerts and things that come on vehicle dashboards aren't considering idle time or the utilization of the vehicle, the load that they're carrying, the environment they're in. So But getting back to this example, the customer swapped from uh, time-based to condition-based maintenance for their oil changes here, and very easy to see on this graph where the little oil can is the time when they change their oil based on an alert from us. So the orange line is warning and the red line is critical. So they would wait till they got an alert from us warning them that they had to have a maintenance event in the coming days or weeks. It's the critical one would be a little bit more urgent attention required. So they changed their oil. You can see the oil change quickly comes back down to a base of approximately 40 CDN there, and then as the vehicle's used, it goes back up to the critical. And my favorite thing about this example, which isn't shown on this slide, but the customer got their alert and the warning alert, and they did their maintenance event apparently, but we sent another alert saying, hey, you still haven't changed that oil, and they called us up and they said, hey, we did it. And I said, the data doesn't lie. So they revisited their maintenance event, and sure enough, they hadn't changed the oil and filter on that day. So they went back and did it, and the graph come back down again. And we do see that a lot. We had another example with a bulldozer in a refuse situation, and the technician went out, didn't change the oil and filter because of the condition. You can imagine what one of those would run through in a day, and it wasn't cleaned, ready for him. So he did everything else, but he didn't do the oil change. And we were able to, back that up with another alert that said, hey, the oil wasn't changed. So the couple of values of changing oil and condition and monitoring it as well.
So it's a good little data backstop even for a business to make sure that somebody's saying, "Hey, yeah, we did this." Well, you'll know for sure if it was done or not, right? So great.
It's good for warranty proof. It's good for historic maintenance records. Probably even add value to a vehicle if you were selling it, because you can prove the history of the service events.
Yeah, that's great. That's awesome. So I'll move to the next one here. Another oil quality situation, but one detecting when maybe there's some sort of problem that's happened, again before that ideal oil change, or maybe historical data that they've had on, this is when we normally change it. And this is detecting when there's problems before that.
Mhm. Yeah. So in this example, this is a high horsepower example, and high horsepower just meaning larger engine example. This specific one's in a mining application, but what's happening on this specific example is that we're monitoring the viscosity here, and as I mentioned before, there's an upper and a lower bound that we put in place for the viscosity. That's where those two yellow lines are on the graph. So, and you can see the green is the data from the actual oil. As it dips below the lower yellow line, that's when we trigger an alert to the customer, and we say, "Hey, we're detecting that your viscosity is too low." And when we do that, it's a customized alert that comes with some direction. So it doesn't just say check your oil, right? It says we've indicated it's gone below the lower threshold. That is indicative of possible fuel dilution in this case. And so please investigate the root cause, and we recommend taking an oil sample. And so the customer was able to take action. They took an oil sample. And when they got the oil sample back, you can see that number there on that third bullet. It's 11.7% of fuel dilution in the oil, which is an exceptionally large number. And what they ended up finding out is that the fuel pump had a seal that had gone bad internally, and so it was just dumping fuel directly into the oil. And one thing that this site specifically, we ended up catching 3 of these cases for this one site in a year. This single case alone probably paid for Fleetguard Fit to be implemented on their whole fleet a few times over in terms of the cost avoidance. If this, if you're familiar with a fuel dilution issue, if it goes undetected for even a short amount of time, the amount of issues it can cause from a catastrophic failure standpoint, and an engine of this size can be pretty substantial. And so the cost avoidance is huge. Obviously, a repair still needed to be made, but you're repairing the minimal amount of parts. You're only repairing what failed. You're not repairing of what could happen down the line if that failure was allowed to continue. And so that's where, from an anomaly standpoint, that's where the system kind of can shine and to help you catch these things, and really optimize what your downtime looks like. A fuel pump replacement is much more manageable than a full engine rebuild, of course, especially one of this size.
And that enables, being able to detect that they can get that piece of equipment back to a maintenance bay to do the service before, something like that could just break down unexpectedly somewhere not easily, accessible, right? And,
Hmm.
especially from a mining
Absolutely.
perspective, I mean, that can create a whole bunch of problems that now you've got to figure out if, let's say, this thing, the engine dies on this haul truck or whatever it is, on an embankment or something like that. I mean, it just creates a lot of risk for the business. And so this is a great example of how this is helping mitigate risk, in that entire operation, being able to
Hmm.
save money, but also just the risk, of all the things that can kind of go wrong. This is able to help you detect that a lot quicker. So that's a great example.
We had another one only last week, Phil. High horsepower, exactly the same scenario. So we're seeing these probably more often than a customer would desire,
Yeah.
but just shows the value of being monitoring that oil.
It would be a lot worse if they weren't able to detect it though. It's just a worse
Yeah.
problem to deal with.
Absolutely.
So you mentioned air filters earlier, and I know this example is kind of pointing towards air filters. Not, doesn't have to be exactly air filters, but in this instance, we're talking air filters. And one of the things you mentioned earlier about kind of the sustainability aspect and just kind of the green aspect of being able to really only service stuff when you have to. I think about air filters. Air filters, even though they, maybe technology wise as a filtration product, don't really have all that much technology baked into them. Air filters are pretty expensive, and especially on some of these pieces of equipment where you might have 4 or 6 air filters, and if you're just changing those things more often than you really need to, I mean, you could be spending a lot more money than what's necessary if the data's providing you with better guidance.
Absolutely. When we say we're monitoring air filters, and I'll get to the slide or the graph in a minute, but we're monitoring the air intake between the dirty side and the clean side that goes into the engine. So quite often we'll get an alert that will stand out from the rest of the say 4 or 6 air filters in mining applications, and it leads to a maintenance event or a lack of maintenance around the air box and the pre-cleaners and everything else like that. So, once again, it's another opportunity to waste the air filter because you're not getting the maximum out of the air filter based on the pre-cleaner and the condition of the air intake. This slide here, it shows how the customer was changing their filters out everywhere where there's a dollar sign there, far too soon. And where the black line is where they could do it at terminal restriction, which we would give advance notice for. So effectively 2.5 times the filter life was available to this customer. And in doing so with the filters, for the air, they were able to extend stage 1 and stage 2 fuel as well. So quite the saving right there. But at the same time, it's important to install the equipment on the entire fleet, not just at 1 or 2 test trucks to try and find that baseline, because who knows what anomaly might occur, like a airbox that needs attention, or I spoke earlier about a truck driving down a dusty road. That might be the anomaly of the fleet, and every other truck in the fleet is on, nice asphalt or something like that, or in mining and construction, if the water cart's not working, perhaps uh, creates a dustier environment than normal. Um, on the fuel side, we've seen and proven, fuel storage has been a problem and created an abnormal filter behavior. So um, that's just the benefits of remote monitoring across the whole fleet rather than just a small sample size as well.
Yeah, because it's easily possible. You could kind of inverse that graph and say, hey, if the OEM recommends service every 500 hours, well, again, air filters especially are very environment dependent. You could easily run into a situation where you need to be changing those filters earlier or sooner than 500 hours, and how would you know, right? So this is a great way to really dial in exactly what's happening with that piece of equipment or with that vehicle in real time. Save yourself, from a potential downtime event, or like in an instance like this, if the data's providing that we're really wasting money changing these things when we could actually double or go longer and give ourselves a uh, better use of the things that we're already spending money on. You kind of take this either direction. So a ton of benefit here from an optimization standpoint. And I think we got one last example here around some of our liquid filters and kind of what that warning and alert looks like. So maybe walk us through this one last example.
Sure. Yeah. So in this example, this specific one is for a lube filter, but the example would apply to really any liquid filter, whether it be fuel or lube. Um, but there's two graphs shown here, and so what the bottom left graph is showing is more of the long-term life of that filter. It was relatively flat for most of its life, and then eventually it began to load toward the end of its life. And then on the right side, this is an actual like an example of an email alert in this case, and so it's going to show the graph is a little more condensed. It shows about the past 30 days or so of that filter, and so it's kind of only capturing that upward trend of the filter's restriction towards the end of it. But the email alert would be what you would receive when you get any sort of thing that crosses a limit. We've mentioned before there's a warning alert and there's also critical alerts, but the difference between the two would be warning is something that you get a little bit of a heads up for. Hey, you want to know this is happening and this is approaching a certain limit where you need to take action. Whereas the critical is going to be, hey, let's take action now. It's reached the end of its life. It's time to address this. In this case, this example shows a warning alert, so you get a little bit of a heads up. And what's in the red box here is kind of an example of what that heads up might look like. It's our prognostics that we offer. So it's saying that the filter is 84% loaded, but the prognostics aspect is when you fully utilize a filter, you get these features kind of get turned on, if you will, or where the algorithms can run even more efficiently and provide you even more useful information. So you get the days remaining that we're estimating as well as the hours remaining. So in this case, 15 days or 147 hours are remaining for this filter life. And so you're able to even more effectively kind of plan how you're going to address this, right? Hey, I might be able to get a little bit more usage of this before I need to bring it in, or hey, I can squeeze it into the schedule that day and take the action needed then. So that's where that's what this slide is to try to illustrate is what we're able to do with the prognostics feature as well as what an email alert would come through. So
And I think that's so cool that it, not only tells you percentage loaded, but gives you kind of a countdown, right? So, like you said, you can start to make a plan and, be thinking about, all right, we need to start from a logistics standpoint, if it's on a site where it's operating, being able to work that in for maintenance, or let's say you are a truck driving down the road and, you're maybe far from home, you can at least be thinking about calling the driver, letting them know, hey, this is the situation. You need to be making your way to, point A over here. We're going to have that lined up for you if it's a terminal. It at least just, again, gives the customer power of information to go and make smarter choices that are going to keep them up and operational, and better efficiency in their business. So I think that's really, really helpful in kind of getting a way to see this. one question I was thinking about is you mentioned the alerts. Um, what would happen in the instance that, let's say, Matt, earlier you mentioned about, if a sensor did break or something happened, what would happen in that scenario for getting an alert? Does it tell you when there's a problem with the actual monitoring? Can you maybe walk us through that?
Yeah, that's a really good question, Jay. Something we've probably skipped over to date is the system is self-monitoring as well, so it's able to send an alert because it's cloud-based. Even if we don't see a message from the telematics box that broadcasts the data, or if we're unlucky enough that a sensor has failed or a harness has been cut or whatever may have happened, we're self-diagnosing and we'll send an alert to that effect as well. So, you're never going to be left wondering what's happening. And then our alerts taper off over time. So depending on the criticality of it, we'll send them kind of, if it's a real urgent one, every day, and then it'll taper off if no action's done, and then it'll taper off to nothing at all. But there'll still be the history over there as well within the portal.
Perfect. Okay. Yeah, that's great. I was just putting myself in the scenario of what if I'm not seeing, what happens if something goes wrong effectively. But that's great to know. It's keeping tabs on itself, so if something's not right, it also lets you know. It's not going to be like your laptop battery that all of a sudden pops up and says, hey, this thing's going to die in 1 minute, you need to plug it back in. It doesn't work like that. It's giving you more advanced
Not at
notice,
all.
which is great.
Mm.
So one question definitely that comes to my mind, are there other types? We're talking about Fleetguard Fit, but are there other types of remote monitoring systems that are out there in the marketplace today, specific to filtration? And if so, kind of what differentiates Fleetguard Fit? Kind of what makes it special versus stuff that may also be out in the market?
Yeah, so we obviously do research on our opposition and what are the remote monitoring systems may be out there. And I've seen marketing uh, brochures, etc., on what some other companies have to offer, and I've even tried to buy some of it just to see what our competition is doing. But I have not been able to buy the system, so I'm not sure what that means. But getting back to my history with the product, I've traveled the world of North South America, through Indonesia, Africa, obviously around and around Australia more times than I'd like to count, and even as far as Mongolia. And I've never come across a system that's been in place, and but there is people that do portions of what we do, but a lot of the time it's not as robust for mobile equipment is probably one of the points of difference of what we do. But when I look at the question, why is it different? You can buy it. Is probably one of the biggest reasons that we're different to anything else.
Yeah, and I think I'll just add to that and say one of the it's easy for well, I shouldn't say it's exclusively easy. It can be easy for folks to take a sensor off the shelf and get data from it. But it's a whole nother step to take that data and turning it into something that's meaningful. And so that's another feature that we have noticed out in the market is that if take oil quality, for instance, if there is remote oil quality being offered by, we'll say, a competitor, a lot of times they're still just offering it up as a raw data, if you will. And so what we have, what's been expressed to us by other customers is that that doesn't really add any value to them. And so they want that process data. And so that's, kind of goes back to the filtration science bit of saying, the algorithms that we're running in the cloud or on the edge computing devices that we've created, we as Fleetguard have created for our product, those algorithms are part of the differentiator as well. So
If I've got a business to run, the last thing I want to be doing is chasing down raw data off of some sensor that I don't know anything about, and then trying to convert that into something that's meaningful to then make decisions based on that. That sounds like a whole lot of stuff that I wouldn't want to do if I'm running a business. So yeah, I think the expertise and experience and the know-how to really deliver it to the customer and make it easy is really one of the huge benefits here. I know one question, we didn't really ask this off the top as we began our conversation, but can you guys just speak a little bit to maybe a little bit of the history and experience of this particular program as a part of Fleetguard? Like, how long have we been doing this, and kind of how did we get to kind of where we are today with it?
Yeah, it's probably we're in 2025 now, so it's 10 years in the making to get to the point where we are today. There'd be more than 10 million hours of data available to us, and it really started off as a way to create customer loyalty with filters, and complement that filter sale, something that others weren't doing at the time. And then we've been able to combine it with different partners in the industry to enhance their systems as well, considering it's just not readily this kind of thing's not readily available and as easily adopted as what our system is. So over that 10 years, it's gone from like a science experiment, I guess, to 2018-ish commercially available. And then yeah, we're here today. So
Awesome. So a lot of know-how, and again, a lot of real world experience and results and happy customers, and a lot of things kind of backing the product up. So I think that's really important. I think my last question for you guys today is, as we think about, well, we're getting to the end. I don't know if this is the last question or not, but predictive maintenance. This is definitely a question that comes up when we talk to folks around their warranty policy by their OEM. So if I own a truck or a piece of equipment and they do say, hey, you should be servicing, this filter or the oil at X number of hours or miles. If that's the policy by the OEM, how does using a tool like Fleetguard Fit kind of come into that equation? Like what's the best guidance we would give on a customer that's asking this question from y'all's experience?
do you want me to take that one, Phil?
Yeah, go ahead, Matt.
Sure. So warranty, I think, is twofold. Like, the data supports the condition, so whether that favors either party, it's the truth. So I guess initially it does support either way. The
Because I think
data.
at the heart of the question, when we've heard this question before, I've heard people ask questions like this. They're wanting to know, hey, is this going to void? Is this going to void my warranty, right? If I take this beyond what they're saying to do in some instance, right? If it's before, obviously that's probably not much of a big deal. But if I'm able to optimize and go beyond what they're recommending, is that something that can cause an issue with my manufacturer?
Yeah, so I'd say in conjunction with the OEM would be the best approach to extend anything. The filters especially, like, most OEMs are so conservative with what they suggest because they're going to do what you mentioned earlier, like the environment they don't have any control over, so they have to be conservative just by nature, and that I respect that completely and understand. The oil side of things is probably extending an oil change intervals where most people need to have a discussion, but we have a long affiliation with Cummins prior to our business being separated, and we've managed to confidently extend engine oil changes with support of Cummins especially. But the two things, like the oil that we're doing the monitoring 24/7. When the engine's running, we're watching the oil, and then complemented by oil sampling. I think it's a strong argument to extend the oil change or the oil drain intervals confidently.
So it's a little, it can be a little bit of a prickly question, and I think maybe a little bit of what I'm hearing you say, Matt, is if you've got concerns about what your OEM is going to think from a warranty perspective, engage them. You guys are happy to talk with them and have a conversation, and certainly to bring the experience that we've got in house to that conversation, and probably make them feel okay about what you guys are trying to do. Certainly, if it's a Cummins situation, we've got a lot of history and background there, and good relationship. But we've obviously got this installed on lots of other OEMs besides Cummins engines. So if you're listening to this and you're curious about kind of what that would look like, at the end of the day, it's good to talk to your OEM